Hello everyone, in this video I'm going to be working on part 2 of my remote plant control project. But first I would like to give a big thank you to Kurtz for letting me use his awesome music in my video. You can go check out his channel, there is a link in the description. Also, if you haven't seen part 1 where I tried to set up the sensors, you can click on this card to go to that video. Alright, so the first thing I did was replace the temperature sensor with the one I used in my first video, because I really couldn't get it to work reliably. Maybe I was doing something wrong or my sensor had a defect, but I was done trying to get that sensor to work and just used the LM35. I connected it to the Arduino as shown on screen. Then I had to get the SIM900 GPRS module up and running. The first thing I did was buy a new prepaid SIM card. I recommend not to buy a subscription, because if something goes wrong, the Arduino can send like 500 messages in half a second. Or just buy a subscription with unlimited messages. You will also need to remove the PIN code from the SIM card, so it never asks for the code again. I'll explain how to do this on Android 9, but if you have another version, you might have to do some research. So the first thing you need to do is of course turn your phone off, insert the SIM card, and turn your phone back on. Then unlock your phone and go to settings. You should see a screen like this. Now scroll down until you see security and location. Of course I've hidden a lot of things because not everyone needs to see my settings and passcodes and everything. But once you get to security and location, open it and you should see this screen. Now scroll down all the way to the bottom and click on advanced. Now open SIM card lock. You should see that lock SIM card is enabled. Just toggle it off. Of course you'll need to enter the SIM code one last time, but then you can take the SIM card out of your phone and insert it into the SIM900 GPRS module. Unfortunately I couldn't find an icon for the module, so here's a picture of how this module should be connected to the Arduino. Once I did that, I just needed a separate power source for the module. I needed a 9V AC to DC adapter which could supply at least 3 amps. Once that was done, I started programming. It took me about 7 hours in total to write this sketch. It might look pretty simple now, but I ran into so many issues at the start. Anyway, here it is. So I'll try to explain the code as fast as possible, but it's not that simple. First we tell the Arduino we want to use software serial library to make serial communications with the module. Then we name the connection SIM900 and tell it to use pins 7 and 8 for serial communications. So each time we use a command that starts with SIM900, we will use pins 7 and 8 to communicate with the module. Then there are all the variables. The string variable can store multiple characters, like letters, symbols and numbers to make sentences and things like that. Int is short for integer and can store a round number. Each time we create a variable, we first define the type, in this case 2 strings and 3 integers, and then set the name, so each time I write SMS string, I am referring to the very first variable in this list. Then we define the default value of the variable. It always needs to be something. For the strings I set the value to nothing, which is technically not nothing, but that's the easiest way to explain it. For the integers I set them all to 0. Of course these variables will all be changed later in the sketch. This is just the default or starting value. Now we get to the setup. This section, just like the first section, will only run once. We start by making sure that both the Arduino and the module are transferring serial data at the same rate. Then we wait 20 seconds so the module can log on to the network. Once that's done, we set the module to SMS mode, then tell it to send all the SMS data to the serial port, so that the Arduino can receive it and use it for all the calculations and everything. The ready is more for testing purposes and doesn't have any real effect apart from making testing easier, so don't mind that. Now you can see that I'm referring to a function called plant update. This function will wait 10 seconds for testing purposes, but if you'd actually use this it would be something like 1 day. Then it will use the sensors to get the temperature and soil humidity, and you might remember that in part 1 I programmed it to make some calculations with the soil sensor to display things like not enough water and too much water, instead of just numbers. So by calling the function, we will wait 10 seconds. As I said, this is for testing purposes. Then it will set soil val and temp val, short for soil value and temperature value, to be the inputs from analog pins 0 and 1. I won't explain the soil sensor since I already did in part 1. I did change one thing though. Instead of printing the value to the serial motor, it saves it as a string in the variable soil status. The LM35 temperature sensor was very easy to program. It's simply some math and then you have the temperature saved as Celsius in a variable called cell. Now we have all the required information saved as a text value in the variable soil status and as a float, a variable which can store numbers and that aren't route, called cell, short for Celsius. Now we set the phone number to which we would like to send the message. You'll have to replace all these X's by our phone number in international formats. Now we start writing our message. First you need to know the difference between print and println, short for print line. So if I write something with print, you can write a line of text and the next line of text will be on the same line. I hope that makes sense. So what if you want to go down one line? Then you use println. This will finish the line it's on, so the next text will be on the line below the current one. So here's how we write the text message. Code line 1. We use println to print plant data. Also make sure you use quotation marks. Code line 2. Since we used println, we are now on line 2 of our text message. But since I want there to be one line of space between plant data and the actual data, we once again use println and place 2 quotation marks because we want this line to be end. Code line 3. We are now on line 3 of our text message. We use print, not println. Then we write temperature. Code line 4. We are still on line 3. Now we don't use quotation marks because this is the Celsius variable we want to print. Code line 5. We once again use println to finish this line. We use quotation marks to write degrees Celsius. You should be able to understand the rest of the message by yourself. Now we send the message. Wait 4 seconds and then read everything stored in the module. Otherwise it might interfere with our message detection system. So now that this function has ended and we've sent the message, we go right back to where we were before, which was the end of the setup function. Now we get into the loop function, which will go on forever, unless we tell it to start another function. Then it will finish that function and go right back to the loop function. We start the loop function by asking if there is any information available from the module. If there isn't, nothing happens and we check it again. And like that we wait an infinite amount of time until we get a response. And then we go on with the code. If there is any information available, we save it to our variable called SMS string. Once again, you can ignore the serial print because it's just for testing. This part is pretty simple. We say if the message contained plant 0, we use the function don't bother, which simply sends valid response won't bother plant. And then it goes back to plant update. And the whole program starts over. If the message doesn't contain water 0, it checks for water 1. If it does contain water 1, we set variable water amount to 50 because water 1 is equal to 50 milliliters of water. Then we use the function water plant, which will send valid response watering plant and then the amount of water. The amount of water is of course the variable we just set. When that function is done, we go back to plant update. If the message doesn't contain plant 1, it checks for 2, then for 3, etc. up to 8. The only thing that changes is the water amount variable, which goes up by 50 each time. So plant 2 is 100, while plant 5 is 250. If it doesn't contain any of these messages, it uses the function unValidResponse to send unValidResponse try again. Then it goes on with the loop function, without ever starting the plant update function. That way it waits for a new message which is valid. I hope I did an okay job of explaining it. Now let's test this thing. I'm really happy I got everything to work properly. In part 3, we'll add the water pump or valve and maybe finish it. I learned a lot, I hope you did too, and of course if you liked the video be sure to leave a like and consider subscribing.